Hi, my name is Josip. I'm the CTO at a company called Sofascore. I've been with the company since day one. And today I wanted to talk to you about scaling a system to millions of monthly active users from first-hand experience. For those of you that don't know, Sofascore is a sports platform that covers more than 20 different sports. And we have users all over the world. And I'm going to be talking about how we grew, what problems we faced, and how we solved them. Here you can see that we have a lot of different data, and the app itself is really, really complex. The platform itself is free and has more than 25 million monthly active users, and they generate more than 1.3 petabytes of data each month. And that's around 350 billion requests every month. Our peak was 1.3 million requests per second. And these are the numbers from the last couple of months. But when we started, we actually struggled a lot with scaling the system. So once a couple of hundreds of users or even thousands of users came online, the app would crash. And it was really difficult to fix it. We have really big peaks. So since we follow sports, when certain sport match starts, you get a lot of users, and then they are on the site for 2 hours, and then they go away. So they would all come at the same time, and the site would crash. So the first thing we are told to do in situations like this, like how do you fix a lot of users that come at the same time, is to add cache. So that's what we did. We added memcache, and we were saving the entire response of a page to the cache. And this worked great. We could then handle multiple thousands of users, and it worked great. But again, at a certain point in time, you just hit another limit. And that's what happened to us. So if you do caching, you save a result so you don't have to recalculate it every time. Once it's expired from the cache, you just fetch it again and then save it to the cache again. But then you have this thing called cache stampede problem. So once something is not in the cache, all of the requests that come get calculated in parallel. And that causes your database or your backend services or whatever to just crash because there's not enough resources to do all of that. It's a cascading failure. So basically what you want to have is you get a lot of requests, but you only pass one request to the database or to your backend service. And this is really difficult to solve on the application layer. And we had this issue 10 years ago when it was even more difficult. So we started to think, how can we actually solve this problem with the technology that we have on hand? And what we did, because we know how our app works, we know that the most popular events are those that are live. We just did a worker that looked at all of the matches that will begin in 2 hours or that have started in the last 2 hours and just fill the cache proactively. And that's called proactive caching. That's actually something that all of the big companies do, like Facebook or Twitter. They just calculate everything upfront, save it so that they don't have to calculate it once the user gets to the page. So it's really important to know how your users interact with the app and with your system. And I saw that we have really big peaks, and we know how the system behaves. So there's this really interesting thing. So 15 minutes before a big match is supposed to start, we have a certain number of users. And in those 15 minutes, the number of users will go 2x or 3x, and it will have a really big impact on the system. And there's this big match called El Clásico between Real Madrid and Barcelona. That's the most followed match on the world. And 15 minutes before that match, the most important match in the entire year, our server was starting to heat up. Like the CPU was going through the roof. And there's nothing we could do. Like we had one server, it was not on the cloud, and you only have 15 minutes to try to fix it. Otherwise, the site would crash and nobody will be able to see the results. So we were thinking, what can we do at this point? And in our minds, we figured out that we're running the backend is on PHP. And we know that Apache, that the web server is much, much faster than the PHP. And it's really fast in serving static content. And so we figured it would be great if we could kind of have this one site, one page, just one page. And if the users go on that page, serve the HTML instead of calculating everything all the time. And that's actually what we did. We went on that game while the servers were still working. We clicked on File, Save As. We saved the HTML. We uploaded via FTP because we were using FTP at the time. We wrote a rule: if the user visits El Clasico, then just return the static content. And it was working great. Like, we saved the server. The only problem was every time a goal happened, we had to manually edit the HTML file. We had to upload it so that it is refreshed, but it was working. It was a great success. But at that point, we figured we cannot do this every time a big match is happening. We cannot be having static content and edit it just for the site to work. So we figured that it's the best way to go to the cloud. Like, the AWS was all the rage at that time. Actually, it was the only cloud provider. And like, our use case with our big peaks was ideal for the cloud. When we have a big peak, we want to scale to many machines. And when there are no users, we want to scale down. And we decided that we are going to move from dedicated server to a cloud solution. And in that process, we took what we learned. We learned that the full page cache is really something that is great, that can reduce the load on our servers. And we wanted to find a software that can help us do that more efficiently. And we found Varnish. Varnish is a reverse HTTP caching proxy. And if you're gonna learn anything from this talk, if you want to take just one thing, this is it. Like, the Varnish is something that helps us achieve the scale that we have. It's the most important piece of software that we have. What it does is basically sits between your users and your backend services and just caches all of the content while respecting the headers. And also, one thing that it has request coalescing. It allows you to solve the problems that we had with cache stampede. It will only allow one request to go to your origin and return the request to all of your users that are waiting for the same content. Our setup on AWS was pretty normal. We had we had an Amazon machine image, which was stateless. It's important for your image to be stateless so that you can scale. We had an auto-scaling group. We had multiple workers, and we got rid of memcache because we just didn't need it anymore. So it's important to be stateless wherever possible because it enables your services to scale. We also started experimenting with MongoDB because web scale. We rewrote the entire application to use MongoDB, to use JSON. And it was working great because it's simple, it works, it can scale. But then quickly we started seeing issues. Like, we had issues with replication. We had issues with data type errors. It was difficult to analyze the data. And MongoDB at that point in time had really big problems with locking. If you wanted to update a collection, it would lock the entire collection. And we have a lot of different games that are live at the same time. So we do a lot of updates. It was really difficult to solve that because the database kept locking up all the time. And also, you don't have foreign keys. And then you have data consistency error issues. And we are a sports platform that does in-depth analytics. And it's really difficult to do that with MongoDB. So we figured, okay, this was not a great thing to do. MongoDB is not the technology for us. So we started looking at some more traditional software, like some relational databases. And we found Postgres. And this is what we use today. We use this today on more than 25 million monthly active users. Why Postgres? Because it's open source. It has advanced SQL capabilities. And this is really important to us to be able to analyze the data. It has minimal locking. This can be a talk all it itself, but basically you can update and read at the same time because of how Postgres works. And it has really great performance. How great performance? We can do 1 million queries per second and 90,000 transactions per second. Transaction is 5 5 actions that change the data. So the performance itself is never an issue. And once we tested this, we said, okay, we want to switch to Postgres, but there was an issue. We have to do it while not shutting down the application because the application is global. So in my mind, it looks something like this. We would have to change the tires on a car while going 90 miles on a highway. And we did it, and it was successful, and that's what we have now. And we lost the simple replication from MongoDB. We lost the configuration, the simple configuration and everything else. But what we gained was stability, foreign keys, and analytical power. So it's really important while you develop the system to recognize the right tool for the job and change if necessary. Also, one of the big things that we added was queues. This can, again, be a talk in itself, which I don't have the time for, but if you don't use queues, you should. That's what allows you to scale. We use beanstalk.d. It's great. So you should queue everything that is slow. And we were in the cloud. Everything was working great. Users came. They went to an auto-scaling group. The auto-scaling group scaled. More users, more machines. But the issue with this is we had Varnish installed on every machine. So the more machines we spin up, the less efficient cache actually is, because every cache is for itself. So the more machines you have, more requests actually go to your backend server. If you have one machine, then one request will go to the backend server. If you had 20, it will be 20 different caches. So basically, this is really simple to solve. You just take that layer and scale it independently of your machines. And this works great, but now we have 2 requests. It would be better if there was one. And the more machines you add to the caching layer, the less efficient cache gets. The solution to this is to just shard. So on your load balancer, when requests comes, you just hash it and shard it, and then different caching servers will get different URLs. You'll basically split your cache into multiple chunks, and then this will work great. That's what we do today, and we can basically cache all of the things. Our cache hit rate is 99.3%, and this is what allows us to be fast and to keep the cost low. But there is a thing, like the cache invalidation is really, really hard, but once you solve it, and you can solve it, your life will be much easier and your system will be really, really fast. AWS was working great, but the thing with cloud is it's really expensive. So we got to the point where our traffic was costing more than our compute. And that's something that really doesn't make sense. So we started looking into how can we reduce our bill for the data. And since we have our caching layer separate, we just thought, okay, we can just move that caching layer away from the cloud and then serve from the cache as much as we can on dedicated machines that are much cheaper and where traffic is much, much cheaper or even free. And then only fetch the things that we don't have in the cache from the cloud and keep everything in the cloud. And it's something that we did, and it worked great. It resulted in a 10x reduction in the price. So just moving our caching layer away from the cloud, we got a 10x reduction. And then once you see how big of a improvement you can get in terms of price, we started to look, can we move some other stuff, some other services? And then we saw that we can actually move everything from the cloud to the data center, over provision all of things so that we don't need to scale the machines, and we will still see a price reduction. So we actually migrated everything from the cloud to the data center, to a dedicated data center because of the price. And the savings were enormous. This is a graph of our usage, of our cost, of our infrastructure through time. And this is in the span of 5 years. And this might not look like we saved much, but when we overlay that with the number of users in the green, you can see that our system grew exponentially while keeping the cost down. And this works really, really great. We also have a really interesting usage. So this is the number of requests through time. And you can see 2 big spikes in the number of requests. That's when big games happen, when you have first and second half. this is what it looks like. So we can get a really big increase and really big spikes. It can get so big that Cloudflare, which we use for anti-DDoS protection, can classify this as a DDoS attack. So we had to work with Cloudflare to have a special rule in Cloudflare where they said, okay, if Sofascore, then just don't do DDoS protection so hard. And that's what we have today. When you have a big system, it's also really important to monitor. This is one example of monitoring. Other example of monitoring is when you have application performance monitor, where you see how your endpoints are performing. This is a screenshot from New Relic, but you can use any application performance monitoring tool. The cool thing about this is you can sort by most time consuming. So you can have a list of the endpoints that use up the most time and then optimize that. And once you optimize that, you can have really big optimizations and performance improvements. But sometimes you cannot optimize. It's already the most efficient endpoint there is. But in those cases, you can usually just increase the cache and reduce the number of requests that go to your server. And this is what we do quite often. So important thing is to monitor everything and then optimize something. And since we are not on the cloud, I also, lots of times I get the question, so what if the number of users exceeds your current capacity? Which is a really valid question. And then what we do is actually, we have dedicated machines. And then if there are a lot of users online, then we just spin up virtual machines, they join the cluster, and then all of the traffic is routed to them and everything works. And the reason why we do this is just because of the cost. So our infra cost is 0.7% of our total revenue. There is also a thing called physics. So our data center is in France, and we have 2 data centers in France, and all of the users go to France. So Europe has really great connection. But if you're outside of Europe, it's not so great. We asked our users in New Zealand and Australia how the app performs. They said, the app performs great. Here's the video. And the video had loading screens. And I've never seen loading screens because in Europe, everything is so fast. So we then said, okay, we need to think about our users and how we can get the same experience to them. So what we did, we increased the caching layer and we set geo routing to route the requests all over the world, and so that the users can get their cache closer to where they physically are. And this resulted in a massive reduction in latency. So we got from almost half a second, which you can see, to 80 milliseconds in Australia, and that's something that users really, really like. You also have to think about data centers, and they can burn. Cloud can also burn. Fortunately, this didn't happen to us, but that's what got us to thinking that you have to have at least 2 different data centers in order to survive things like this. And if you have 2 data centers and you're on-prem, Kubernetes is the way to go. So we use Kubernetes because it's data center aware. It's easy deployment. We have same code on all machines. We do easy upgrades. Rollback is built into Kubernetes. It works great, but if you don't have to use Kubernetes, you should really think to, not everybody is right to use Kubernetes. It's really hard. If you have your team and they want to use Kubernetes just because it's the new hype, you have to think really good if you want to use those. We also do real-time updates. To do real-time updates, we have a pub/sub server, which is open source. It's called NATS, and it works really, really great. It's free. It has support for clustering, and it's what enables us to have really fast score updates on our apps. Also, we have a lot of data. We collect every click that happens in the application. It's anonymized and it's sent to our servers. So there's a lot of data, and we have to analyze those. And we are not on the cloud. So if you were on the cloud, you would just save it to Google BigQuery or whatever. But we have to do it ourselves. And the way to do this, if you have on-prem servers, is to use a database called ClickHouse. It's a really great database. It basically allows you to have a lot of data because it's compressed. You can do a lot of queries that go through big chunks of data. And it's also free. That's most of what I wanted to tell you in these 20 minutes. But to take home, the most important things is be stateless wherever possible, because if you have state on your machines, it's really difficult to scale. This is something you should think about early in the process, because later on it's difficult to decouple your state from your services. You should know how your users interact with the app, because that enables you to build out a system that's much more optimal and that can perform better and take advantage of the technology better. If you know how your users interact with the app, you can kind of design around that. And like, this is the most important thing, is to cache all of the things. Usually people say, okay, but I have personalized content. This is not something that can be cached. It can be cached. Like, everything can be cached. We have personalized content in our app. There are techniques you can use to kind of split the content and have it be cacheable anyways. We have 99.3% hit rate, which means that 99.3% of requests are actually returned from the cache. So less than 1% of the requests go to the actual backend services. And that's what allows us to have an infra that costs just a fraction of the cost it would usually cost. And you can have really fast app and a really fast service. This is one of the most important things that is usually overlooked. It's difficult to do cache invalidation, but you can do it. Also recognize the right tool for the job and changes if necessary. You shouldn't use something just because it's the latest hype. You should use something that can solve your problem. There is no right answer for problem A or problem B. It depends on what problem you're trying to solve. Queue everything that is slow. There's just, today, everybody talks about microservices, but nobody actually tells you some of the basic things. Is just queue. Just put everything in the queue, and then you can scale your workers independently of your system. And you should monitor everything. Everything you have should be monitored. You should have a good insights into your system. You should have good observability, because then you can see what's not working as it should, and then you can optimize some stuff, not everything. That's basically what I wanted to talk about in this presentation. Thank you. You can find me on LinkedIn, and if you have any questions, I'll be happy to take them. Also, you can write me on LinkedIn with any issues that you have. I'll try to do my best to help. Bye.